Hi, my name is Pablo Galindo.
And my name is Łukasz Langa.
And this is the core.py podcast, a new podcast where we discuss the internals of CPYTHON and other adventures in making a new version of your favorite programming language. We are back from the United States, from PyCon, and we are ready to resume our regular programming. And this is episode 12. Not every podcast survived long enough to hit this milestone in particular, but we are here. And we promise that once we arrive to this particular number, we will do a stupid episode. What do you think about that, Łukasz?
Well, as compared to all the series episodes that we've done so far.
Right. This is especially funny because if you recall, when we were doing the live recording at PyCon, there was some I don't know if it was Bernardo, someone that asked like, are you going to ever run out of ideas? And the episode that we are going to make today, kind of like it's like when you see these animes, like, you know, I don't know, Evangelion or something, and then there is this weird episode that is just like a recompilation of everything that happened.
Oh yeah, like the Friends, the sitcom, also had these.
Yes,
like, almost every season. Yeah,
it's very annoying, but
filler.
We are not going to. We are not. It would be very funny to just put like snippets of like all other episodes, like the funny parts,
the best of.
Yeah.
Well, but in any case, like there was also like always some semi-plot that tied into all those things. So like, you know, it made at least a little sense, and you could be tricked into thinking it's a full episode, but it never was.
Right. Yeah. I mean, you need to give the illusion, right? Like we give the illusion that we are serious core developers, and not
honestly, the thing is
jokesters.
This: there was one super weird episode in Breaking Bad about a fly in the lab.
Oh, right.
Like literally the entire episode was like no plot that was actually moving the story forward, just this fly. But it was such a good episode anyway, because it was just showing the
It was very celebrated, right?
Yeah, it was really something silly, but like actually it worked out really well.
Nice.
So yeah, we hope this one will as well.
Do you know what also works really well, Łukasz? Some of these cool things that we have here today. So because we are here to talk about what the fuck Python, we are going to start with a classic, Łukasz.
Yeah.
Let's say I have two variables, A and B, and both are equal to the number 5. Then is A is B, what it will return if I say A is B, like true or false?
If I have A equals 5, B equals 5, A is B will return true.
Wow. Of course, because both are 5. That is true.
Right.
And what if I try a negative numbers? Negative numbers are weird. What if I try with -4? Like A equals -4 and then B equals -4. Is that true?
A is B will return true.
Wow. Makes sense. But have you tried with like, I don't know, like the forbidden number, 300? 300 is always the forbidden number.
300 is always the forbidden number. Okay, we need to now actually go ahead and look at whether we have any magic numbers in the source code for 300 in particular.
It's an interesting number. So do you know the uninteresting number paradox? This is not related to this example, but like the theorem says that it cannot be uninteresting numbers. Because if there is one number that is uninteresting, then all the rest are interesting, and this one is not, which makes it interesting. So there is no uninteresting numbers.
What?
Let's say, like the question: are there any numbers that are uninteresting? And then you say, let's say there is one that is uninteresting.
Yes.
Then because only that one is uninteresting, it makes it interesting. Because why that one is uninteresting and the rest are not?
Oh, okay.
They cannot be uninteresting numbers.
I get it. I thought we were going into shit like if a person is supposed to say a random number from 1 to 100, like most people will say 37 for whatever reason. It comes up way more than any other number, which is weird.
Oh, wow.
Yeah.
Okay, that reminds me of a magic trick, a trick from a magic trick, which is quite interesting. So this is psychological magic. It's quite cool. So let's say you say, think of a number between 0 and 20, but high, so it's more difficult. Do you have one?
Yeah.
Is 18?
No.
Ooh, which one it was?
19.
Okay, close by. So the trick is the following: you give them a car or whatever, and then you put like the car, the 18th from the top, and then you do this experiment. So normally people like the thing that you say is very stupid because you say between 0 and 20, but you say higher, so it's more difficult. It's not more difficult because it's higher, but people won't contest that sentence and they will think something around normally 18. Because it's like round and like people don't like spiky numbers, so like the 18 is there. Normally they pick like 17, 18, 19, so you sneakily like pass one card extra or one card less.
I see.
And then you do the classic when you put like, you don't say if it's the next card of the card that you're going to put in the table, so you have a plus and minus one of advantage. Quite impressive when you do it consistently.
Yeah, because what you might not know is that Pablo, apart from working for a fintech corporation and apart from being a physicist specializing in black holes, and apart from liking REPLs and parsers in CPython, and apart from playing classical guitar, is also very good at card tricks.
Right. Thank you very much. You are warming my heart. Now you need to put like heart-warming music. Okay. Well, anyway, let's go back to our example. So 300. If you do the example with 300, what will happen, Lucas? A equals 300, B equals 300, A is B?
False.
False, right. Why is that, Lucas? Tell us the secret. Why 300 now is not 300?
So Python understands that there are numbers that are used all the time in your source code. Usually those are smaller numbers. So the first 256 are going to be always kept by Python. So they're pre-allocated, they're going to be there if you're using them, and they're going to be the exact same object every time, because we assume that most ranges, most uses of integers in your source code in literals and so on are going to be smaller than 256. So all those are going to be essentially, interned. I don't know if that's the term for this particular thing, but yeah, they're going to be kept in memory for you. But any other arbitrarily large number is not, obviously. We cannot just keep everything in memory. That wouldn't be faster
right
at this point anyway.
By the way, the hard mode for this is now sub-interpreters, because this is like caches and whatnot,
Yes.
and every sub-interpreter has its own number. So technically you could compare them across sub-interpreters, they will still be false.
All right. Yes.
All
so
right.
So A is B is false for A equals 300 and B equals 300.
But if you do A equals 300, semicolon, and then B equals 300.
Well,
A is B?
not sure. It seems like there's a trick there.
Well, it depends. Correct. It depends. It depends if you are in CPython REPL.
Yeah.
Well, actually, I don't know what we do. No, in the new REPL as well. In the CPython REPL and the new REPL, the new REPL, that will be true. But if you do it in IPython, it will be false.
Why is that?
It's the way you detect if you're in IPython. Like, no, it's false. This is because, AST optimizing. Wow, AST optimizing. So this is because when we are constructing we parse A equals 300, semicolon B equals 300, why are you laughing at me?
Because I have bad news,
You're
man.
destroying my explanation.
I have bad news. pyrepl also says false.
No.
It does.
No.
Just try it.
No, I don't believe you. No. How can this be? No, wait. Let me check in normal Python, because now I'm lying to our people. No. This has to be X. Yeah, okay. So normal Python does it, and pyrepl doesn't do it. No. What is this? No. Wait, I have the perfect sound effect. This is really bad. I'm going to fix this. I'm going to fix this crap. I don't know why is this happening. Well, I don't know. I don't want to start thinking about what the fuck is happening. Man, I lied. Oh, wow.
Not the first time that we're learning about Python from our own episode while recording it.
Error. Yeah, not good. Okay. Jesus Christ. Okay. The reason this used to be true, apparently, in all versions of Python, is because when we construct the AST for this, there is a phase of the AST that optimizes the tree, and then it figures out that both of these values are the same. So to make the AST smaller and therefore the code object smaller, they duplicate constants. This code was actually heavily implemented by heavily optimized by Sergei Storchak, I think, back in the day. There's other things that are duplicated, and there are other transformations that are done in that way. For instance, if you have I don't know if you know this one, but if you have a set that is full of literals, so for instance, you do the set 1, 2, 3, 4, 5, is automatically transformed into a frozen set. Mm-hmm. Wow! In the cases when it matters. So for instance, if you are iterating over it, like if you do for x in, and then you do a set 1, 2, 3, 4, 5, that is automatically transformed into a frozen set, because we know that you're not going to mutate that unless you do weird shit. But like. That makes it smaller. So yeah, don't use this. I suppose that's everybody knew the one.
Okay. Yeah, that's interesting, because even if you do in the REPL create a function, right? So you create a function def f colon, and you say global xy, and you say x equals 300, y equals 300. If you call this function in the REPL, then x is y returns true. Because the entire body of the function has this optimization that you said.
Well, man, you are nerd sniping me live. This, how bad is this? Because you're not a reliable companion of this podcast. Stop doing this shit. Let's continue. We have more cool things.
We do.
Let's say the following code. Lucas, think about it. Now you think about this. Let's say I do the following. Try 1 divided by 0. And then finally return 42. And then I put that in a function, and I call the function. What will happen?
So we have a def foo with try 1 divided by 0, finally return 42.
And then I call that function. What will happen?
Then we're going to raise this division by 0, and when we do, we're going to get into the finally block, and the finally block will see the return opcode, and that opcode will execute, so that's it. There's no exception anymore because we returned.
So Lucas was saying that because only core developers listen to us, they wouldn't say, oh, they know all of these things, right? But okay, Mr. Core Developer that know all of the things. Where is the exception? Because as you know, when you raise an exception, the exception is put on a global variable that is on the runtime state or the thread state.
Right.
So what happens with it? Because you're returning with the exception set. So who cleans the exception?
That is interesting. Because we were raising, but now we are no longer raising. We just returned, so I don't know who is. Yeah, that is unclear to me.
The exception is never raised for real. It's just on the stack.
I see. Okay, so 6 sys x info is empty, and it was the entire time.
I think so. I think if you print it in the finally, it's going to be empty. That will be very embarrassing if it's not.
Yeah, let me nerd snipe you again.
Wow, man, stop nerd sniping me.
I started editing it in the old REPL, and now I don't have multi-line editing, and I'm already crying.
It is not 0. It has exception. So it's set.
Maybe when you're calling it, then it gets set at that point, because there's a zero division.
I don't know actually.
Huh?
Maybe it's the return that is cleaning up. I don't know. Well, it's happening. It's happening. Well, I don't know. Man, I don't know everything. What about the JIT? What about the JIT that happens in the middle? What happens? Where is the exception? Well, we don't know. Maybe I think what happens is that indeed, you reify the exception in 6 to the exec info. But what can happen as well is that it's set, and then in the finally returning the finally just being clean, because you cannot leave the eval code with exception set.
Yeah, this is
that
interesting.
Is not being propagated.
Right, we can check after, but definitely finally has some ordering features, the kind of the behavior of it is very often surprising to people, like what the order is, especially if you do have other things than just try finally.
Yeah, there is the classic when you have try except finally, and then you return in the 3. Which one gets returned?
We actually, I think we had this on one episode.
Yeah, we mentioned this in the bad podcast.
Yeah.
But with this being funny, so going back to the real episode, so what is really funny is that I find a way to way optimize this and transform it into a stupid prank. I mean, if you control your the REPL of the person you are making the prank to. So if you instead of dividing by 0 to create an exception, you sleep or something, and then you call this in a loop. You cannot stop it using Control-C, because every time you press Control-C, then it raises keyboard interrupt, but the finally swallows the exception, so you cannot stop the loop.
Yeah, that
A classic.
must be frustrating.
I'm pretty sure there is some hits of this in GitHub. Like, people do very weird things.
Or it might really be just an effect in real world code. Like, it's not going to be this.
I just realized this is the most unhinged version of suppressing. Do you know when you don't want an exception being like raised?
Yeah.
That you do with context lib suppress?
Yes.
And you just want to suppress everything. This happens a lot, like suppress exception. So you do, instead of that, to avoid the context lib import, which is very heavy, you try finally.
With return.
Friends, just do this. It's going to end very good in your code reviews. Instead of using context lib suppress exception, try finally.
Yeah, with a return.
Yeah, and put that thing in a local function or something, and then call it. Beautiful. Okay. Cool. Okay, Gukesh, more questions. Let's say the function all. Do you know everything about all? Do you know all about all?
I know enough.
Do you know enough about all?
Enough to be dangerous.
Okay. You have an approximate knowledge of all. What happens if I call all with an empty list?
Well,
Is true or false?
all takes as an argument a container. So if that container is empty, then it's going to say true, because there are no elements, meaning there are no falsy elements. So true.
Correct. Very good.
Which is weird. Yeah, it's weird, but like it's something I actually had to learn in practice. And honestly, it was surprising to me at first that an empty container all returns true. It would seem like if there are no elements, how can all of them be truthy? It's
because it's defined the other way, right? It's the number of falsy elements. So there is no falsy element.
Yes.
But there is a deeper meaning that I don't want to get into, because this is not, I repeat, this is not an episode about pedantic Pablo. But like, if you use all, like, there is like in category theory and like group theory, if the neutral element needs to do something that composes well with the rest of the stuff. And if you define all of nothing to return false, then it doesn't compose very nicely with the rest of the stuff. But we are not going to explain what is the neutral element of what category of what group, so we are not going to go into that.
Yeah.
It's just that makes sense. It's the same reason why people are surprised that 0 factorial is 1.
yeah.
Like, why 0 factorial is 1? Because it composes nicely with other things like the definition, right? Because like, like n factorial is n times n minus 1 factorial. So if you have, for instance, 1 factorial, that will be 1 times 0 factorial. So if that is 1, better 0 factorial is 1. Because if you define 0 factorial as 0, then all factorials will be 0.
There will need to be an edge case.
Yeah, well, you cannot. You need to undefine it.
Yes.
You need to say that doesn't exist. Like, that doesn't 1.
Like division by 0.
If Hood was here, he will enjoy this discussion.
Yeah, exactly.
But he's not here.
So in any case, all of an empty container is true.
Right, but what about all of a list that contains an empty list?
Well, then it is a container of a falsy element, and that falsy element is the only element. So you would say that there is a falsy element, so false.
That is also correct. Wow, very sharp. And what about if I have a list that contains a list that contains an empty list?
Well, we're not actually digging that deep when we're running all. What's going to happen is we're looking at the outermost list, and then we're going to find another list inside that has elements. So it's truthy. We don't care what those elements are. It all is not recursive. It's going to just stop there. And that's going to say true again, which is weird.
It's weird.
But yeah, it's what we're doing.
Doing these questions to core developers is boring.
Yeah, so if we want to make this more core developer-y, we had this thing not about all, but about any with Hinek a few years back, where we were really kind of annoyed how any is just defined wrong in Python.
Wow.
Because any is like you provide it with some iterable, and then it says, okay, true. Because something was returned from, like, something there was truthy. But wouldn't it be better
if it returns the thing that is truthy?
Yes, right? So we literally made a package. It is on PyPI to this day. It's called first. Because like we fought for a bit to add first to build built-ins, to actually have this in Python, because it felt like we really should have this where It's not any like true. Like, who cares? Like, you just return me the thing. It'll work in if and everywhere else, like, as a true
But I
thing.
mean, there is already an idiom that does this, right? Like, you can do a generator comprehension that is like, so you do next, and then you do x for x in my container if whatever filter you want.
Yeah, sure. But, like, it's just information loss. So,
Yeah, but then it will not be any. It will be called first, right? It's all about the naming.
Any would be any truthy is fine. And it just... the implementation just returns the first one every time, but like that would be maybe an implementation detail, or maybe it would be actually defined that it's always the first one because we stop consuming the iterable at that point,
right?
Which would make sense for like, infinite iterables, right?
Right.
So let's talk some more about iterators then, because like, clearly we like how this is non-obvious every now and again. So say you have a tuple just of 3 elements. A equals 2, 1, 3.
Okay.
Right? So there's a tuple of 3 elements, 2, 1, 3. And we're saying sorted of A equals sorted of A. So the same thing on the left side, the same thing on the right side.
Okay.
Sorted of A, which we know holds a tuple of 3 elements, equals sorted of A.
Mm-hmm.
So what is...
Well, that is true, right? Like, I mean, it's going to return the same list sorted.
Yeah.
Which I'm very annoyed by, because like I always feel that it's wasteful that sorted always returns a list.
Yes, I also like had this thinking many times, but like it is just kind of simpler to implement in the sense that like you just sort into a new container. Like there is .sort on the list specifically, but sorted accepts anything.
Right.
So if you just provide it with some range or whatever, like, kind of it needs to have a container to write to.
Yeah, but why the hell will you return like a mutable container instead of an immutable container, right? Because like that means that every time you want to iterate over sorted elements, you need to construct like a stupid list, which is slightly bigger than a tuple, for instance.
But we might ask Tim Peters about this. Like there might be
maybe so you can do in place sorting, so you construct like a list of empty things and then you start like shuffling shit around in the container.
Or there just might be like a pragmatic reason that like whatever you have sorted, now you're ready to, I don't know, like pop elements from it or whatever. So it's it might be just useful. It might be a good compromise. I don't know. So okay, so let's try the other thing. So sorted means we sorted, but if we actually want to sort it the other way around, we might say reversed of A equals reversed of A. What is that going to return?
That's true as well, right? It's just the same case, but like the other way. What's happening?
No, that doesn't work. No. So if that was a list, that would be true. But what the reversed of A is...
Oh, it's an iterator.
Yeah.
Oh, wait a second. No, it's a generator. No, an iterable.
It's an iterator, yeah. It's a custom iterator for reversing, actually.
Right. So reverse A creates an iterator, and then reverse A creates another one which are not consumed, and therefore I just compare by identity.
Yeah, those are two different objects. And why would they be unequal, actually? Why would Python make it so that reversed of A is not equal to another instance of reversed of A?
Well, because you don't know what they will contain once they are consumed, right? I mean, there are different objects. Like when you can, for instance, have like one of these objects. So reverse A, you capture it somewhere, and then you consume one value of it. You call next, and then you try to make them equal. Like they need to know that they have been consumed to compare equal or not, right?
Right. Because the object will be the same. Let's combine it then. So let's just say B equals reversed of A. So we hold it in a variable. So now there's just one.
Okay.
And say sorted of B equals sorted of B.
No, now it's false, because the first one will, like, sorted of B will construct our friend the list.
Yes.
And then it will consume B. And then the next sorted of B will iterate over something that is consumed already. So it's going to be an empty list, which is obviously is false.
Right.
Wow.
Yeah. So the point being that things cannot be equal based on their transient state.
Exactly.
But they could be, right? Like you could make.
I mean, you can make them compare equals. To be honest, like you could do it. It will be very happy to know if two iterables contain the same elements. But like there is many things here. One, once you have an iterable, like you need to iterate to know what it contains, right?
Yes.
For what is worth, that thing could like fetch some value from some random database and bring it to existence. So like you don't know what it contains, and even if you for whatever reason consume it first and then you put it back somehow, then you need to know which ones have you been consuming. So for that is basically equivalent to having a container. So you just better say that these two are different objects and that's it. They don't define equals.
Right.
I mean, sorted, like we do the special things for ranges, right? Like for instance, ranges, I think they properly implement equals. So range 010 is equal to another range 010 because like we know the range object itself, like if they are equals or not, even if they are technically iterators.
Yeah, so that's what I mean, because if you actually want something to be hashable, that's different, right? Like you need to make sure that the hash is preserved across the lifetime of an object. And the reason why is that if you put that object somewhere in a set or a dictionary, you need to know that this is going to be the same one, so you can address it. Like in a set, you can check whether the set contains the object, and on a dictionary, you can use it as a key, so you can actually refer to whatever the dictionary holds under that key. So the hash needs to be the same.
Right. That sounds very smart, Lucas, but are ranges hashable?
I don't think they're hashable.
They are hashable. Ha, you are wrong.
Wow.
Yes. Check it out. The hash is also negative.
Hash of range of 10. Oh, it's negative and huge, but it is actually returned.
Wow.
Which is interesting because range of 10, if you call iter on this will be a range iterator.
Yeah, well, but this is interesting explanation. But the important part is that you were wrong.
An iterator or a range iterator is also hashable.
What?
Yeah. We are learning Python as we go here.
No. You mean like hash iter range?
Iter range is just returning some number.
No.
It's
Jesus. It's true.
Yeah.
What the fuck? Well, is the default hash? That is the ID? No. Okay. Interesting. Well, maybe it's a salted version of this shit.
It is very interesting because you can just say next on that thing, and now it moves. So
And the hash is the same?
And the hash is indeed the same.
Oh, the hash is the same. So I don't know. Is this some stupid thing? So you can put like range, like iterable of ranges in a fucking like dictionary or something like that, and then you just consume from the keys. That will be very unhinged.
Maybe there is some weird algorithm like somewhere in Nuth that used this. So somebody just made it so that range iterator is indeed hashable.
Right. Now that we're talking about hashes, what is the hash of 5, Lucas? Hash of 5.
5.
Oh wow, very good.
We just use this as an optimization.
What is the hash of -5?
-5.
All right, because hashes can be negative.
You just use the actual number. Yeah.
Is this? What about hash of -2?
-2. Yeah, same.
Yeah. What about the hash of -1?
Well, yeah.
You're wrong. I don't care what your answer is. You're wrong.
Okay.
What is your answer?
So it's not -1.
It's not -1.
Okay.
It's -2. Oh, wow.
Okay, so let's make a class C, and we define dunder hash, and we return -1 from it.
And then you hash the object?
Yeah, you hash the object. Like, what will we return?
It will be -2.
Really? Wow.
Yes.
Okay.
It will be -2. Yes. It will grab your -1. It will say like, this is cool, but you know what is cooler? -2. -2 is cooler.
Oh,
wow. This is technically known as BM poisoning. BM poisoning, what is that? So BM poisoning is when your implementation detail, like you normally implement like a language on top of another language. And when the underlying language that you're using to implement the outer language is influenced by the internal one that is in some circles, it's called BM poisoning. So this is because CPython is implemented in C. Wow. What a surprise. And you know what is -1 in C? It's very popular.
it's some error condition.
It's an error return. Exactly. So the hash function is going to call some stupid hash function implemented in C. And that can fail. And that will return -1 to fail. And then we need to distinguish -1 as a failure from -1 as some hash is -1. So what the internal function does is that if the Python function returns -1, it transforms that into a -2, so it doesn't collide with the error return.
Yeah, this is a very popular problem in C, which makes some of the new C APIs that Peter added actually have unobvious function signatures, right? So you only use the actual return from the function for the status to know whether there was an error.
Well, the classic one that is stupidly annoying because it makes the API like slower, and there is a bunch of those. It's like pylon from long or something like that.
Yeah.
Because pylon as long.
Yes, exactly.
If you return -1, you don't know if it's because it failed because you passed like a string or something, or because it was the number -1 in Python that now is the number -1 as a C long. So you need to call by error occur, which is expensive.
Yes,
well,
you
I mean,
need
it's
to
not
check
super
whether
expensive.
there was an error or not. So the new APIs, what they do is you have the return value just for the status, and then you just have some pointer that you just point at some memory where the actual result is going to be put. Even if it's an integer, you need to provide a pointer to where to put this actual result.
That is kind of cool, but the problem, the one thing I hate when I write this is that you always need a local variable for holding the result.
Yes, exactly.
So
Yes.
you end with this pattern when you say like, int result, and then you pass the address of result to the function. But it's very annoying because if you have 6 call of this and those are like always different types, you need to
need to
now
have
have
6.
result
Yeah.
1, result 2, or like the result, or like maybe result, or whatever it is, right? Like it's not great. It's not great.
Yeah,
Okay, but you seem to know a lot of stuff about hashes. But which one is the hash of like float infinity?
Oh, I don't know. Like
Is the first 6 digits of pi.
Oh, interesting. I never knew that.
It is 314159.
Is this actually a special case in the code?
Is a special case. Yes,
okay.
yes. There is a case when it's hashing floats, and we cannot put Easter eggs everywhere because the branch will potentially make Mark Shannon unhappy. But because this is only in floats and infinity needs to be like take as a special case, there is a hard-coded value. Do you know why it's also weird?
Yeah, I have plenty of things, but which one do you
Okay,
mean?
you got this. Let's say if you get this one. So this is you got the integral one. But what about this? Let's say you have a, and then you define a equals something, and then like the string something, and then b is also the string something. So now you do a is b. Is that true or false?
It's going to be true because we are interning strings.
Oh, very good, very good. But what about if you do like, let's say, a equals Gukesh, and then b equals Gukesh? A is b?
Yeah, so I'm intimately familiar with examples like these. Yeah, so we actually have a very short alphabet of characters allowed for string interning. And this is not going to be true. This is going to be false. A is not B.
Gukesh is not equals to Gukesh.
And the reason I know this was because of PEP 563. When we implemented PEP 563, we had this understanding that, hey, not only we're turning every string, every annotation to a string now, so that takes up less memory, and now you can do forward references and a bunch of other nice things, but all of those strings are interned, right? Because they're just they're just Latin ones, so that should be very useful because most annotations are really types that look the same, right? Most annotations in your source code are going to be like list of string or something like this, or like optional something. So it turned out that no, actually almost none of those types are interned. And the reason why not was that the types very often contain the opening square bracket.
And
that thing is not in the alphabet for interning.
Right.
Yeah. So I know that like if you are,
if I recall, the rules are like is ASCII letters, digits, and I think the only extra character is an underscore, right?
Yeah. Essentially, it was the old style identifiers, because now new style identifiers you can just define Łukasz equals 1 and that'll work. But yeah, like that, in the rules of interning were really old.
I think it's also for function definition and things like that, right? Like you cannot have a function called Łukasz.
No, you can.
You
can.
Can you define Łukasz as a function?
Yes.
Oh yeah, you should be able to, right? Yeah.
Yes, because it's a name. Course. So if you wouldn't be able to do this, then like how you would be able to actually assign it to that variable later. So
Right. Makes sense.
Now it's time to word stories from CPython. So
PR of the week. Bang. Let's start with you. Which is your PR of the week?
All right. I think both of our PRs of the week are going to be predictable. We're working on the REPL. So
yet again, what is
we're going to be working on it until we retire, because
this REPL will become our tomb.
Some of those REPL details are revealing things that we didn't expect. For example, Python has a bunch of REPLs. There's the one that everybody uses. Just when you say Python 3, it's going to launch a REPL. But there's more. You can say Python -m asyncio, and that's going to launch you another REPL that allows for two things. First of all, it allows for top-level await. So you can just say await and some async function or some coroutine. And it's going to be doing this automatically. You don't have to say asyncio.run of that thing. You can just say await and it works. But more importantly, you can also create tasks with asyncio there, and they're going to just keep executing in the background.
Right.
So like that's the interesting thing. Is like you can start a server, you can start multiple other things, and still
very cool.
Yeah, have this nice REPL. So obviously, when we created pyrepl in 3.13 for beta 1, we missed adapting the asyncio REPL to this. So I did that. This is now part of beta 2, so I'm happy with this. However, this took a while to get right, because, okay, the APIs of pyrepl and the code interactive interpreter that we were using before, like interactive console that we were using before, are a little different. So yeah, we had to massage the kind of APIs here to work with one another. But there was one other weird thing that Guido pointed out, which was that, hey, there's this situation now that actually Control-C, so interrupting the command, is not actually doing anything. It's not actually interrupting. And I discovered that it was even better. Actually doing Control-C was executing what was already typed, which is not good. Right. So I had to figure out what is going on. And in the end, the reason was that we actually use two threads for the asyncio REPL, and the main thread is going to surprise you. It's not the interactive thread. It's not where you type commands. It's the asyncio thread.
So you're typing commands in a thread.
Yeah, you're typing the interactive things in a thread. Ooh. So this is done such that a bunch of other things written in asyncio kind of assume that they run on the main thread. Since in that case you have the default event loop and whatever. That used to be the case. Now in 3.13 we are at a point where we cleaned up a bunch of those weird cases with those assumptions, but still, because of some of those small differences between running from a main thread and running from secondary threads, Yuri decided when he was adding the asyncio REPL that the main thread is going to be asyncio. So now the interactive part of the REPL is running on a secondary thread. And what makes that weird is that, well, threads don't actually handle signals in Python.
Yes, only the main thread receives the signals.
Exactly. You're going to lose all those signals, one of which is sigint, is Control-C. So the solution to this was kind of weird, because we identified that alongside the sig interrupt handling, what is happening is the terminal is also going to send a character. It's just the hexadecimal 3. Character by
like
3.
a circumflex accent 3, right, or something like that. Circumflex.
It's just byte 3. So it's end of text essentially.
Right.
That actually goes so far as to the Morse code in ASCII. This is why it's number 3, because it was so fundamental. It goes all the way back. So this ETX, which is this symbol of this one character, is actually being sent by the terminal. So I used this to just re-raise keyboard interrupt, just in a dumb way, so that we could actually handle keyboard interrupt. We might be tweaking this, I'm hearing.
Because people want the entire text of Frankenstein to be pasteable in the REPL.
Oh yeah, that's a long story. Pun not intended.
People don't believe me when I say this. Like, hey, how is the new REPL going? It's like, yeah, everything is good except that you cannot paste the entire text of Frankenstein. It's like, haha, how stupid you are.
Well, you can, or you only need to wait 20 seconds, but and nobody's got time for that. So we need to be faster.
No, 20 seconds now. Before it was before it was much more, like hours.
Okay, right. So now we have the optimization there. So yeah, so the asyncio REPL now is nicely colored and has multi-line editing, which is nice.
Beautiful.
Right? And uses pyrepl, which is nice, and does Control-C correctly, which is nice. And we identified that in 3.12 there was some regression that made things get
that's
weird.
an interesting thing, because we had this discussion, very Eastern European discussion, when I'm like, hey, Google, what about all these things? And you're like, no. You're wrong. What's going on? Okay, so we discovered that because I was saying no, but your new keyboard interrupt is cosmetic, because the only thing this does, if you do Control C while asyncio is executing, you do I don't know, sleep, and then you do Control C, that is a signal.
Yeah.
That is a signal that arrives in the main thread and interrupts your sleep and then continue. That is true. But you Control C while you are in the REPL, or for instance, you don't write anything and then you Control C, it prints keyboard interrupt. So that is just a code that prints keyboard interrupt.
Yes.
It does not really raise keyboard interrupt, because if you try to use the signal module to override the handle for sigint, and then you make it print or whatever it is, that is not called, because the only thing the code does is printing keyboard interrupt. That is not Gooka's change, it's something else that was already there.
Yeah.
That is the regression. But then this means that this is just cosmetic, it's just fake keyboard interrupt. So we are fixing that to actually handle this, which also is useful, because if you happen to be one of those people that paste the entire text of Frankenstein, and then you I don't know, for whatever reason you don't want to paste it anymore, you repent yourself, then you want to cancel it with Control-C, and then you want that to work, because otherwise you need to wait 20 seconds, which is now impossible. You shouldn't be able to wait for 20 seconds. And that needs signals to work, because otherwise, if you handle it the way Lucas was describing, then that particular character 3 will be enqueued after all the input for Frankenstein, and only will be raised at the end.
Yeah, so you're going to keyboard interrupt after you spend all those hours or 20 seconds.
Well, you will be technically correct, which is the best kind of correct.
Right.
Keyboard interrupt was raised.
Yeah. Okay. So just before I pass, the baton to you, let me say this. People are like, how do you have multiple REPLs in Python? How many do you have? So how many do we have?
We have the normal REPL, the vintage REPL.
Yes.
Vintage REPL.
Vintage.
Then we have the pyrepl.
Yes.
Then we have the asyncio REPL.
Yes.
And then we have code.interact, which is supposed to spawn a REPL, which we kind of are using, right?
Yeah. Do we have any other REPLs in Python?
Well, yes, we have the SQLite REPL.
Exactly.
We have the SQLite REPL. Help and you can help and PyDoc.
Yeah, PyDoc would be okay, let's say yes.
Okay, so 7 REPLs. We have more, right?
Yeah, I guess there's can you call PDB as a module? I guess you can.
Yeah. Right. You can.
So yeah, so that would count as well, because you essentially start your program with PDB. You can do
8 REPLs. Wow.
Yeah. So people are like, how many REPLs do you need? Oh, many. And by the way, I just ran SQLite 3, and it doesn't have multi-line editing.
But can you paste Frankenstein?
You probably can. I don't know. Like we might try this for 3.14 to fix this, so that
the Frankenstein thing.
Yeah.
Is almost there.
Because pink is the new black. Now you have to have like a colored prompt. If there's no color prompt, like what are you even doing?
Yeah, when you see the color prompt, you know you are in the real business.
Exactly.
Yeah, color prompt for everyone. But you know what is very annoying? My PR of the week, PR 119843. PyREPL now honors PyOS input hook. Do you know what PyOS input hook? I didn't know what it was 2 weeks ago, but now it's my nightmare.
You know
I
everything.
I hate this. Yes, I hate it. It's the worst thing. So okay, dear listeners, let me tell you about the story of grab some kind of marshmallows, like put your home fire on, and like go close to the heat to listen to my story about PyOS input hook. So PyOS input hook is some stupid function. Yes, I'm qualified to say this. So it's a stupid function, and a stupid function can be set. It's not even an API. It's a symbol that is in C. Like you just override the symbol because like who needs APIs? You just have a symbol and you put your function there. And if you put a function that doesn't have the correct signature, it just blows up. Because who needs type safety? Anyway, so it's a symbol that you can override in C, and then the documentation says, I'm going to actually read it. PyOS input hook. So this is what we say. PyOS input hook can be set to point to a function with the prototype in function void. So it's a function that returns an integer and receives nothing. And the function will be called when Python's interpreter prompt is about to become idle and wants the user to boot info from the terminal. The return value is ignored.
Yeah.
Overriding this hook can be used to integrate the interpreter's prompt with other event loops, as done in the modules_tinker.c in the Python source code. Yes. Okay.
Yeah, that doesn't say much.
And this is a lie, because it's not all that it does. There is all these funky secret rules that this function has.
Yes.
For instance, the function. First thing, so how we learn this? Because I say Guka said, oh man, we are not overriding this function, the world is going to explode. And they say let me fix it. So I said, wow, it's just a stupid symbol. Let's use C types.
Yes.
So I use C types, and I use this. For the first time in my life, I have the opportunity to do this. I implemented a C-types callback. Mm-hmm. So this cool thing was you pass a Python function and it uses the secret JIT compiler inside C-types to create a wrapper. It's very cool. So I implement an input hook in Python using C-types, and then it blew up incredibly. It just exploded. And the reason it exploded is because the function drops the GIL around it. Oh, so this function is called without the GIL held. Mm-hmm. How the fuck is this? Where it says that? It doesn't say anything. Kaboom! So you try to put a Python function there, well, it's going to explode because it needs the GIL. Maybe no GIL is the solution for PyOS import hook. Maybe that's why we are doing no GIL. But yes. So first rule, that function is going to be called without the GIL. So please don't touch Python. And if you touch Python, please ask for the GIL back, because exactly. Otherwise, nah. And then we were saying, okay. So we need a wrapper that maybe routes the GIL and whatnot, or just re-implementing in C. But then Gukas was like, but man, this is kind of weird, because look, I tried to override this in C with a stupid function that just prints hello just to know when it's called, and look, I'm not touching the REPL and it's constantly printing hello. It's hello all the time. So this function, when the documentation says this function is called when Python is just going to become idle, well, they forget that this is called every 100 milliseconds because when Python is idle.
Yes. So it's not once.
It's all the time. Every 100 milliseconds, this stupid function is getting called. So it's blank until you actually type, and then it's not called again. So people use this actually. People use this, for instance, matplotlib uses this for some reason to integrate with the CPython REPL and Tkinter. So because you need to be able to press buttons and shit. So you press a button and then something appears on the REPL.
Yeah. So we might have actually started with this. So how is this weird hook useful, right?
Right.
So it is useful when you have matplotlib and you have some plot that you want to display in your REPL. So you import matplotlib, you have some data, you put it on the plot, and then you just say plot show, right? So what's going to happen is suddenly you have this new window that appears, and you can actually interact with this new graphical window. But it's sort of weird that you can. It's weird that you can press buttons there and actually cause things to happen. It's weird that you can resize this graph and see it resize. You know why that's weird? Because in Python, you are now still waiting for another command to be typed. There's a prompt. You can type command. So there is something happening there where...
And there is no more threads. There is no more threads.
That's not even threads. Yes, that's the thing. It's like you can type a new command in Python. So how is different code being executed there to make sure that everything redraws?
Well, now you know.
Because of the input hook.
You can only press buttons slower than 100 milliseconds because you press buttons faster than 100 milliseconds. No. So that's it. So yes, so we discovered this abomination. And then we had to like re-implement the whole thing. So now it can be called from Python. So we implemented a secret wrapper that I'm not going to reveal here. That is in the sys module. It's called sys underscore input hook or something like that. There is two actually. One to set if it's set and one to call it. And then if someone puts the input hook, then we call it from Python, and then we do this stupid thing of calling every 100 milliseconds before we do it, which is quite stupid because like there's a busy loop. And then if nobody says the input hook, we just block, obviously, because that's more efficient for the CPU.
Yes.
So yes, it was very painful to learn all these things, and it was even more painful to re-implement PyOS input hook based on a non-existing like description of what it's supposed to do, because like obviously we don't want to break PyQt and Tkinter and Matplotlib and all these people, which are really nice, and we don't want to hurt them. But it's very hard for us to implement a replacement for something that is not actually like there is no specification. So like we had to check with all these libraries, but we did it, and it was very painful, and I hated every second of it. But it's done.
Yeah. So many thanks to Thomas Caswell, who is the maintainer of Matplotlib, who first of all initially let us know about this being a problem that we don't actually do anything with PyOS input hook. And then actually he did give us some feedback on what are the important things that we should be looking at so that they work.
Well, I have to say something actually.
Yeah.
Yes. So Thomas Caswell, this person, like I admire your comments. Like this person just wrote this exquisite bullet point list of all the different like libraries that are being affected, and he like searched for all the different things and created these ginormous comments with like nice explanation and code examples and things. Like man, I'm a maintainer, so I know these comments that don't appear from thin air. Like you need to spend minutes like looking at things and pasting and like pinging maintainers. So thank you very much. Your work doesn't get like ignored. Everybody listening to pyrepl, just think about this person and thank them in your mind, because this is fantastic. Also, thanks also to Michael Drotboom. Sorry if I'm mispronouncing your surname, because he also like raised some concerns and he mentioned all these guild problems as well. So we are very grateful for the help.
All right, and that brings us to
what's going on in CPYTHON.
All right, so let's start with this. We got 3 new core developers joining the team.
Wow!
Yeah,
and I promoted
the last
one
episode. Right,
yes,
that's amazing.
Which are the new core developers, Lucas?
So we have Russell Keith McGee, currently focusing on Python on mobile platforms at Anaconda. He's the lead of the Beware project. So Anaconda now is kind of hugging that. So we're very happy to see this. But he's also known as a longtime core developer of Django. And he made a PEP about iOS being a supported platform for Python. And that PEP is already implemented for 3.13.
Awesome.
That's amazing.
Work.
So obviously this was one of those cases where how is he not a core developer yet? So now he is. That's great.
Awesome.
Then we have Michael Drotboom that we already mentioned here, actually. So he's currently the manager of the Faster Python team at Microsoft, but also known as the original creator of the PyOdite Python distribution for the browser that Hood is working on, that Hood is maintaining, and which PyScript is based on. So it's very dear to my heart.
Yes.
So yeah.
He was also the maintainer of Matplotlib, I think. He was also involved in the Laden Swallow project, and he's dedicating the days now to work with the PyPerformance benchmark suite and all benchmark stuff on CPython.
Right, that's very cool. Like, a person who is involved in many parts of the Python stack like for quite a while. We're very happy to have him on the core team. Another case of like, how is he not yet? So
exactly, yeah. That's why I said like, man, like we need to promote this person. So I did.
That's amazing. And the third one is Tian Gao, who is an extremely active, a new contributor. Like he only started contributing last February, and only in a single year created over 170 issues and PRs.
Impressive.
Including the implementation of PEP 667. We're going to talk about this later. And now he's focusing on making PDB, our built-in debugger, better. And we're also going to talk about this more later.
Right. And he was mentored by Bram Booker, our favorite JIT person.
Right. Yes. So congratulations. We're very happy to have all three of you on the team. And we managed to reach the number of new core developers that we got over the entire year of 2023.
So we have our
That
quota.
doesn't mean the quota is reached. That doesn't mean we're closing our doors. Hopefully we're going to get even more people to help us. Like it's a very fun and active project now. So we're very happy to see more people join us. That's extremely valued, especially such experts as Russell, Michael, and Tian. All right. What did we do since the last episode?
We released Python 3.13 beta 2 with a lot of pyrepl improvements. So that's awesome. And we also released Python 3.12.4 with a lot of bug fixes, some of very important ones, like the tokenizer bug that we discussed the other day.
Yes. But yeah, let's talk about beta 2 then. There were like 58 PRs.
58 PRs, man. Look,
pyrepl.
I'm so happy. This makes me so happy. Not because it's what we're working on, to be honest. It's because one of the things I wanted when I tried to convince you originally to start working on this is that we said like, man, if we made this in Python, everybody will fix these problems, and it happened.
Yes.
Oh man, this is such a beautiful moment.
Clearly.
Everybody was like working on the sprints. It's fantastic. It makes me so happy when people contribute back to things that they want to improve.
So give me your top 3 things.
Well, it will be a dishonor to not mention the super fantastic work that Dino has made from Meta. So he was extremely nerd sniped by us. He indeed managed finally to produce pyrepl support for both the new Windows terminal and the classic cmd.exe that should just die. But he did both, like amazing, incredible, amazing skills, better person. And none of those things now require readline or courses. And it works with feature parity. I don't think we're doing anything fundamentally different.
Yeah.
Maybe bracket paste is the
in
only
fact,
thing missing.
we still require curses on the Unix platform. So Windows support is more inclusive now than the Unix one is.
Well, you cannot have curses.
Most installations will have curses, but it's not guaranteed. Like it is optional.
Right. But yes, thank you very much, Dino. You are the best. We love you. Also, the other one that is quite cool is that we dropped the readline dependency ourselves during the sprints for Unix platforms, but we still record courses. And this was the stupidest dependency on the stupid planet because it was a one-line change that Lisandro's made, and because we wanted a class called RL completer.
Yeah.
And we could have perfectly import RL completer and get the class from that module. But instead of that, we imported readline and we call get completer with the false to give us RL completer. So we input an entire dependency on readline, which is like, a nuclear power plant required to get like just a battery.
A Python class that we already have in the standard library.
So it was an easy fix. Yes. And the third is quite cool. Is that we already mentioned the input hook and asyncio, but we should also mention that when typing code, the REPL now correctly auto-indents thanks to a new contributor, Aaron Jari from Apple. Man, it's fantastic to see Apple people like contributing to Python. I think it's the first one I see actually.
So that one, I actually I worked with Arnon during the sprints on that change and like the follow-ups and whatnot. So it was very nice to see how productive people can be when the REPL is written in Python. So I can just say like, yeah, you were entirely right that this is the right kind of movement towards actually having more pieces in Python. So hopefully in future versions with Brand's work, it'll make sense to keep more of Python in Python. Not quite PyPy, right, grade, but still,
Well, I'm happy to say that we are now faster than PyPy when pasting code, even if they have the
yes, with just the code pasting, yes. That pyrepl in PyPy still just does kind of brute forcing screen recalculations every character. Yeah.
But yeah, auto-indentation is fantastic, man. Today I had to show like a small example of how super works to college, and man, it was such a fantastic, it was magical, man. I was so happy that the person was asking me like, why are you so happy? It's like, man, because like I have to create like 3 classes with like the same methods, like an init that prints, right? And then I wanted to create like the same class with different names, so I could just up arrow and like just change the name of the stupid class and just enter, and then I was writing the init and it auto indent, so it took me like a second. I was like, man, this is so cool, it's so ridiculously cool, and I can do it, and it's great, and there is colors, and it's fantastic. I was over myself, like fantastic. Yes.
I like this a lot. Right.
Talking about Tian Gao. So what is PEP 667, Gukesh?
Right. So PEP 667 not only has a cool number, but it is fixing a long-standing issue in Python where locals is kind of a weird object, because you have this dictionary that it returns you. But if you are changing your locals in your function and you look at locals, the dictionary you got, they might go out of sync. Better yet, if you look at frame.f_locals, that can also go out of sync with both the dictionary and the state of the actual locals in your function if stuff is changing. So there were plenty of edge cases around how that worked. And people couldn't really rely on the fact that, every time you update one, the other is going to be in sync. So PEP 667 says, actually, let's fix this. Let's make it more obvious to the user that every time you're getting frame.f_locals, this is going to be the current state of the locals in the function.
Right.
And every time you update the locals, the frame.f locals you already got is going to stay up to date. So that was actually accepted as a PEP like a while back, and it was written.
We need to mention that Lisa Colham had a previous version that was trying to document how it actually works, and it's just proposed some fixes, but it was such a big one, like that it was super hard to actually push forward. So this is a simplified version of
right, yeah. But the important piece is that like PEP 667 is not a new PEP, right? So it was added like 3 years ago, essentially. And
it was Mark Shannon says, right?
Yes, but it was written by Mark Shannon. So it took us a while to get an implementation that is easy enough for us to integrate. And Tian Gao did that. So now all of those things I said like were important for the PEP like are now implemented. So that's great. Obviously, during the implementation, some additional edge cases were identified, which means that now Tian Gao is in fact a co-author on the PEP, since there were changes kind of required to that. And Alisa Coglan is still working with Tian Gao on some of those. So it is...
Yeah, like the CPYTHON, right? Like the returns borrow reference.
Right, yeah. It is almost entirely solved by now, and the edge cases that are being worked on now, like really hairy, like they have the right people on it, and Tian Gao is one of those right people to have. So I'm very happy to see him work on this.
Yeah, I'm super happy that he's also working quite a lot in PDV. Like this makes me super happy. One of the things that, man, I don't know if you ever have this problem, but this is like super annoying. If you put breakpoint at the end of like a backward edge or a branch.
Or a function, yeah.
Yeah, the function is especially annoying actually. So at the end of the function, you put breakpoint.
Yes.
It will break in the next instruction, which is out of the function.
Very annoying.
So you plan to inspect locals, they're gone. Very annoying. So he made a change that now breakpoint immediately enters the debugger like where it is, not in the next line.
Yes. So that is change in behavior. So we were like debating whether this is, something that we can actually make.
No, but there is no debate, man. Like it's just,
But it is such a better default.
Yes. I had to put pass many times under the breakpoint. So it's so stupid. Something that he already worked on is basically entering expressions with closures like leak comprehension generators and lambdas are now supported in PDB, which was also really important because otherwise was like doing this weird thing when like getting like variables that are not existing and it was not picking up correctly the scope. Very, very annoying.
Yeah.
This sounds like a joke, but I don't know if you know it, but PDB is built on something called BDB. And then there is PDB.PDB and BDB.BDB. And PDB.PDB inherits from BDB.BDB. It's true. So that's the base debugger. Then I don't know if Sandwich actually uses that base class, but now that thing supports opcode events. So you can like step one opcode at a time and things like that.
Yeah, that is also
very cool.
Especially for
colorized exceptions are now printed just like in pyrepl. This is like spam, but like it's true. Like he basically hooked into the new colorized traceback that we implemented, and in Python 3.13, and PDB uses that as well, which is very cool.
Right. So all of those improvements really nice to see, and Tian Gao is not stopping there. What we had in 3.12, also thanks to Mark Shannon, was this introduction of sys.monitoring, a faster way to instrument the program that is running.
Right.
And what Tian Gao wants to add is the debugger that we're using to actually switch to sys.monitoring. We were initially skeptical of having a big change like this from the existing set trace, get trace API that the debugger is using right now, since there are some differences that cannot be overcome between the two APIs. That is essentially why sys monitoring was added, to make things faster, but now not everything is possible in it exactly.
Yeah, we cannot change BDB.BDB because there is backward compatibility concerns.
Yes. But now there is a new proposal by Tian Gao, about how it can be an additional option to just plug in sys monitoring if the user opts into that. And that is way more conservative than what we have initially discussed. And that is looking way more promising. That's right. Maybe in this kind of pluggable way, that will enable a debugger where you can keep running it, right? So not actually breaking on things, but just say continue until some watch is going to be, seen or something. And that running code is going to be almost indistinguishable in performance compared to regularly run code, which now is very far from being true, right? Like the current debugger is way slow.
Yeah, you cannot set breakpoints. It's very annoying. Yeah.
Speaking of performance, if you are turning a string that contains some digits, right, into an integer with int of string, this is now asymptotically faster than before. Tim Peters spent a long time optimizing the algorithm, essentially just changing the algorithm of how this is working, being inspired by what Decimal is doing. So Python used to have this tagline that we read Nuth, so you don't have to, around the language, carefully selecting good core data structures and algorithms. So you as a user, if you follow the idioms, you'll be fine. And this is an excellent example. If you go to the PR, which is 118751, you will see some of this hardcore algorithmic optimizations and discussions around okay, is this actually faster asymptotically? What's the complexity of that? Some of the discussions there even foresee future possible optimizations that looked promising. Tim actually went ahead and tested them, and they weren't that worthwhile, so they were dropped. And there are still maybe some fruits to be gathered from that tree, but they're no longer so low hanging. So this essentially landed at a point where Tim was like, I'm burned out on trying to make this even better. This is good enough. So now it's already faster than it was before. It's one of those inspiring changes where few people can make them. And who, if not the person who literally has a sorting algorithm named after him? So,
But we don't use it anymore.
we don't?
No, it was called team sort,
Yes.
and now we use a stronger version called power sort.
Power sort.
Power sort, yes. There is a it's a very beautiful talk in PyCon US last year, I think. Yes, I think so. When the author of that PR explains the entire algorithm, it's kind of like a funky merger with like some this concept of power, I think it's called, or something like that. Like that basically tells you how to merge it in more efficient ways. Again, it's just asymptotically better, but now it's the algorithm we use. It's called power sort.
Very cool.
Cool. Do you know why it's cool as well? It's the third time I say this, but like it's true. Well, actually, just to change it slightly, something that is not cool. Do you know why it's not cool? The fact that datetime is not thread safe.
Oh, yeah,
because it's a
we
lot
mentioned
of hidden state there. Kind of weird model. And that was because basically there's, as I said, there's a bunch of global state. And you know what doesn't like global state? Sub-interpreters. They don't like global state. So basically that is bad for sub-interpreter. And now is fixed. They use a per-interpreter state, which obviously, if this is fixed and it affects sub-interpreters, the PR is from obviously Ericsson, which is the person that has painstakingly go through every single global variable and global state and substituted that by a better version that encapsulates it, so you can actually use the module safely in sub-interpreter, which by the way also helps for no-GIL in many other ways.
Yeah.
Just because and embedding, which is fantastic. It's a lot of hidden work. But Eric has been doing a lot of it, if not all.
Yeah, that was pretty cool.
So thanks, Eric.
And speaking of things that like need to change, PEP 649 needs to be implemented at some point. So Jelle Zistra started doing this and quickly noticed that, okay, we need to actually know a little more about what the expectations are around how we will be phasing out the imperfect PEP 563 and from future import annotations, and how we will use dunder annotate, how this is going to be supported in a standard library, how third-party libraries are supposed to interact with it, and so on and so on. So there was enough of things that needed specification that he grabbed PEP 749, which I find like a very elegant kind of numbering scheme, right? Where PEP 649 is, okay,
We just need 100 peps until we keep fixing things.
yeah, this is a change, and 749 this is how we're actually implementing this change. And apart from this PEP, Jelle already landed adding dunder annotate to classes, so that's already there, and is working now on the compiler changes that are required by dunder annotate. So we're getting there. That's very cool to see that this is actually finally moving forward, since
Which is fantastic. Yes.
I've been asked about this problem being in the air as author of PEP 563 many times. So I'm very grateful to have Jelle work on it.
Yep. Awesome. So another cool thing that happened is that Bernie Gale made os.fwalk and shutil.rmtree support arbitrarily deep directory trees by replacing a recursion with a stack.
Yeah.
Which is something that it may sound easy because a lot of interview questions require you to do this for simple cases, but this case is not because it's across like 300 functions. So just very good work.
Yeah, so there were many PRs to actually address different parts of this. I reviewed some of that, and I have to say that they were like very pleasant reviews, since not only is the code like really easy to read, but even the cases that are sort of more complex, when you pointed this out, like, I'm not really sure what this variable holds, Barney would be really responsive to be like, okay, I can actually rewrite this a little bit, or I can add a comment here to actually make sure that everybody else understands it when they read it later. So,
But
very cool. What is happening?
Pedantic Pablo has something to say.
Okay.
Technically, my dear Gukas Langa, you could already have arbitrary directory trees because Python inlines function calls from Python to Python functions. So you could arbitrarily raise sys recursion limit to whatever you want and call shutil.rmtree and os.fwalk, and it will not segfault. it will be stupidly slow, and you risk segfaulting if someone changes the evaluator loop,
Exactly.
like on a memory, for instance. But yes, apart from that, you could do it. You could do it.
And also, I understood that this is only like Python to Python calls, right?
Yeah, of course. If you have a C call in the middle, but it is very weird that you will have a C call in the middle.
Yeah, so
like if you have a C call, like you can have Python that calls C and then C finishes and goes back to the same frame, and that doesn't reuse.
And that is fine because
I mean, it uses one when it goes C, but when it goes back, it's the same frame, and it keeps reusing that.
Oh, okay.
The only problem is that when you have C in the middle. So, for instance, functools.partial. Yes, no, yeah. Functools.partial. When it calls a function, it calls C code because it's implemented in C, right? So when you call a function that has been partialed by functool.partial, it consumes a stack because it needs to spawn a new evaluator loop because it needs to go through the C call of functool.partial. So if in that case, you can, so for instance, you do shutil.rmtree and then you functool.partial, something like that, then it calls segfault if you raise the recursion limit arbitrarily.
So what you're saying is technically it would be possible, but it might be...
Pedantic Pablo out. Pedantic Pablo out. Finish. You cannot prove me wrong, Lucas. I keep saying that. Do you know what is also cool? Like, let's talk about free threading. Everybody loves free threading.
Yeah, you can always nerd snipe me about free
so Don't Hina makes some cool things. In particular, it makes so the FT builds, the free threading builds, because you will not hear a steering council member say anymore. By the way, look, man, sorry, parentheses, sorry, don't he, just wait for a second. So I have a new person in my team. She's fantastic. It's called Ivona from Latvia, I think. And Ivona, the first thing that it has made is basically to make available the 313 free threading Python at Bloomberg, right?
Yeah.
And, we have this build script and whatnot and blah, 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 blah. And man, all the name of the interpreters and all the name of the variables were no gil. And I was like, no, man, they are going to find out. They're going to find out that this no. So I asked her, like...
It's BBPy again.
Yeah, so I asked Ivona, like, let's change all of this to a letter T. And she's like, well, T for what? It's like, it's free threading. So now we are changing all the variables from no gil to T. So Ivona, if you're listening to this, you're awesome. You're awesome. Thanks for working with me, changing this no to this.
So like
work.
As you were saying this, I was like, this is why I was like not a big fan of T, right? Because it is T as a letter, but it stands for the sound th, because it's threading. So it's kind of should be TH, cool. And then it will be like, okay, it's th, but then it kind of sounds weird. Like every time you say like, oh yeah, well, like we have this thing. It's like it's I kind of wanted to have like N, because obviously it's like, oh, it's no. So like it's N, but also it's like N sounds like new, so it sounds like kind of new generation.
T is one of these letters that most people don't even pronounce when they are speaking fast. Like the other day, I think it was an XKCD comic, if I recall correctly. Like if you see people saying in a sentence "hot potato," you will realize that nobody pronounced the T without looking alien. Like hot potato. Like it's so weird to do it. But yeah, anyway, going back to Don He. Sorry, Don He. So he made that the free threading builds are now marked in sys.version by adding an experimental free threading build to the string. So obviously, if you want just the version, you can use sys.version info. That doesn't control this spam. And this is also visible if you use Python -VV. I've been told that the Spaniards cannot pronounce properly this letter, obviously, because we don't distinguish the sound, V and B. But I have practiced a lot, so I can say V and B. Vampire.
Appreciated. All right. Brett Simmers made it so that the GIL can be enabled and disabled at runtime.
Wow.
So that was like, will we actually need this? Yes. And we are using this internally, for example, when running init on a newly loaded C extension module. So the reason why that is important is that we don't know for sure whether at that point that C extension is compatible with free threading. So we are temporarily enabling the GIL for this process. And then when the C module declares compatibility with free threading, we can disable the GIL again. And that was one PR. But then we obviously realized there are edge cases. So Brett also worked on a PR to make sure that the GIL is only dropped only if your thread that says drop GIL was holding the guild in the first place.
Right. You're going to drop something that you don't have.
Exactly. You cannot, yes.
Yes.
This required actually paying attention to this status in PyThread state. So like for the longest time, like that wasn't really just kept in underscore state, and now we do keep it, and that fixed a crash in test multiprocessing, so that's good. Like now we are in a better position, and also like just being able to enable and disable the GIL at runtime seems like we're going to be using more
I mean,
of that
everybody is going to use it. Like tools like Memray and profilers and things like that will certainly need to do it across weird stuff that we need to do. I'm not going to disclose.
So yeah, and also Brett refactored our thread sanitizer configuration to contain more specific suppression rules. So what is kind of very surprising to us is that for the longest time we were hearing that, well, thread sanitizer is very useful, extremely useful, but like it is so unlikely that you're going to be able to configure it in such a way that you're not getting hammered by false positives, that you're not going to be able to use it. And yet, like, there is a working thread sanitizer for us for Python with memalloc, with reference counts, with all those weirdnesses that we have. And it is very useful in finding real issues. For example, those datetime problems that we were mentioning, like Tisan was pointing those out.
And Tisan was also pointing the counters that don't count, right?
Yes.
Yes, a classic. I like that one. Yeah, and I think the rest is that, for instance, the rest of the changes, like Dino, our favorite Dino, you're awesome. So he fixed thread safety around lookouts for the type cache in the face of concurrent mutators, which is quite important.
Yeah, and we also mentioned Arnon Yari. So he didn't only like add auto indentation to pyrepl, he also fixed thread safety in iterators.count. So pretty impressive.
Counting works across multiple threads. And our one and only Sangros, he basically reviewed all these PRs, or most of them, and authored even more changes himself around basically interning, thread safety, object immortalization, and fixing tests were run sequentially on running PGO tests for the free threading build, which is very important. And Sam is doing fantastic work. He's working super hard, like super responsive when we came to him with issues. I'm extremely surprised how well this is going so far. We literally... Like I did this thing when I had to do it with like, sticks and stones because like half of the world was not working and things like that. But I basically recreated one of the biggest packages that we use internally at Bloomberg. It's like it's ginormous. It's a C extension. Is the final boss of C extensions. Like 400 megabytes of binary. It's just brutal. It contains the entire world. And then I made a free threaded build of this.
Yeah.
After physics and Python problems, and man, it worked out of the box. Bang! I mean, we know it's incorrect because we are relying on the Git for synchronization in some places, but that's our fault technically. But man, I'm surprised how stable this is. It was almost linear scaling, so with 10 threads, we were getting 8.5 times faster.
Wow!
With a CPU bound functions, yeah, fantastic. And this is like it's highly non-trivial. Like, and it's also using some weird C++ ownership rules that will be destroyed in presence of threads. Like classic, you have a parent object that creates childs, and then you destroy the parent, and then you try to destroy the children, and they're gone. So all of these work. Like, man, I'm super surprised how resilient the free threaded build is going. So this speaks like super loudly about like the fantastic work that Sam has been doing, but also all the contributors that we have mentioned here, and many that we don't have enough time because this episode is literally right now as I'm speaking 2 hours. So yeah, I just wanted to do a shout out to everyone here on how well this is going so far.
Yeah, I'm pretty sure we're gonna cut this episode down somewhat in post.
Yeah.
You're seeing very many things that we're saying, including those that we might want to edit out, and then we're leaving them in because anyway. But yeah, like we might trim it down a little. To be clear, like the reason why we're procrastinating on true work and just saying like, oh, let's just talk about some weird stuff that users of Python might find, is that the next thing that we really want to do is to do a deep dive on how we manage memory in Python. And that will require us to spend multiple episodes on this, since this is just too big of a subject to just cover
Very
in
confusing.
one go. So
Exactly. Yeah.
so we want to talk about reference counting. We want to talk
Like why we have a special Python allocator, why we cannot just use malloc, or like how the DC works, or like
exactly, and how memalloc is actually now like essentially that allocator. We wanted it to be optional for a bit, but now like no.
right.
Yeah,
Or why if you print the
gonna be
reference count
thing.
of like none in 313 is a super big number.
Yeah, and it's yes, and especially like we're going to be talking about how free threading and subinterpreters make this somewhat
Funky.
harder. Yeah,
Funky.
so
Funky is the word.
this is going to be like 3 or 4 episodes, maybe not in a row. We're going to sprinkle like some interviews in between, but yeah, this is some bigger work ahead of us, so we need to plan this a little bit ahead. So yeah, this is now the end of maybe last silly episode, but yes, episode 12.
No, the last silly episode, nah.
No, the other ones are going to be purely professional, and they're going to be all business.
All business, all business. We will be wearing ties.
Yeah, there's going to be no more jokes. Yeah.
Yes.
Yes.
Okay. Thank you very much, everyone, for listening.
See you
Until the next time.